Okay, in this demo, we're going to go over a Strands Observability project, which it's labeled, it's under Agentcore Observability, agent not hosted on Runtime. We're in the Amazon Bedrock Agentcore samples repo, and I just navigated down to this folder right here. And I'm in the Strands right now. There's different demos. Let's see, where am I over here? I'm going to bring up the terminal. Yes, so I'm in the Python virtual environment, where all my packages are. I'm in PyCharm, and I'm looking at a Strands observable notebook, and I just ran this pip install force reinstall requirements. Now look at the requirements. The requirements have some packages. I did get some incompatibility errors, but I'm going to move on. I'm going to execute this cell right now and see what happens. And I get an error. Resource already exists. Strand agent logs. So what I'm going to do is I'm going to go over here, the Strands agent logs. And I'm going to delete the log group. And now I'm going to go up here and create it. And it got created. Now here's a log stream. Got created. Let's see what we're looking at here. Log management, log group. Let me refresh this page. And I'm filtering on Strands agent here. So we should be able to see the log group now. Very slow. Okay, I got my log group. Let's go in here and see. We do. Let's just move forward with the demo. Okay, now we have a log stream. Dun, 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 dun. Now I'm going to write this file. This writes the .env. Supposedly this uses .dev, so I'm not going to worry too much about it. I'm going to run this. Well, it's going to write this file, right? So this file is getting written. So now, where is this file? It's up here. The file got written. And let's move, so let's see what it says. It from dot environment, it loads dot environment, defines these open telemetry variables, and let's see if we run this. It's telling us what the variables are. Now this is an AWS distro package, and there's other things here, and it's using part of Strands. I think of Strands as AWS, but it's its own package, so they seamlessly work together. So what I see a little bit different here is Python configurator and some logs pointing to the log group of the attributes. It's a little bit different than the other demos. It's using the .env, so I'm not used to this. Now it's going to write this. Now it's going to write this file here. Let's see what this file does. it writes a file called Strands Travel Agent. It imports a logger, it uses Strand agent and tools. It configures the Python logger, sets the level, and then it has this tool where you had doing a web search with a query, and it used DuckDuckGo, and so let's not be as concerned as that, but when they get the results, they're formatting it and they're returning the formatted results. Okay, and then as you get Bedrock model, this here was a tool. So the tool Strands can introspect the function and tools as available, and could automatically figure out whether it's smart enough to invoke that tool. But let's see what the Bedrock model does. It uses Anthropic Claude Haiku model. It defines the West region, use the model ID and the region, and the temperature 0. That's a little odd, but they want it to be accurate. Maximum tokens is 1024. We might get a problem with that. I think I ran this before and I got, because it's going through a loop, that we might exceed the tokens. Successfully initialize Bedrock model in the region, and if there's an exception, throw an exception. Get Bedrock model. So the Bedrock model, you initialize the model by this does the instantiation of the Bedrock model. And now you have a travel agent. Okay, you got the model, you got the agent, and then you have the tools. So let's see, this travel agent points to the model. It points to a system prompt. You are an experienced travel agent specializing in personalized travel recommendations with access to real-time web information. Your role is to find the dream destinations matching user preferences using the web search for current information. You should provide comprehensive recommendations with current information, brief descriptions, and practical travel details. And then they define the tools in the agent to be the web search. So agent has model, system prompt, tools, and Bedrock model pointed to Claude. Well, the agent is using the model, so the agent has the extra information, the maximum tokens, the temperature, the region, etc. So I think what I was trying to elaborate on down here is you have an agent, a travel agent that uses a model, and here's where I guess the model incorporates the model ID, the region, the temperature, and a maximum token. Just so happens the agent uses that model, and a system prompt and tools. Okay, so that makes sense. Query: research and recommend suitable travel destinations for someone looking for cowboy vibes, rodeos, and museums in New York City. Use the web search to find current information about venues, events, and attractions. This would not be me. I'm not interested in cowboys and rodeos, unless I watch that movie Nope, where there's an alien involved. But anyway, the point is that now the travel agent runs the query, and you print out the results. So really, all it does is write this Strands travel agent right here, this file, and the file is the cell I'm looking at, and now what it's doing is it's running the agent. Let's just see what this does. This is running the Strands travel agent. Now usually a Strands travel agent would be running an Agentcore with an app entry point, and would be communicating with MCP and just hitting on that agent endpoint, and even getting information about its tools and stuff like that. But here we're just running this thing, locally, seems like, and we're instrumenting it, so we get some instrumentation. So let's see what happens here, and if and I'm getting a warning. It looks like some dependency doesn't match, and like I said, it's hard if you go through all these demos. It's hard to keep up. You'll be going around in circles because one project uses some version, another project uses another version. What I can say is, if you want to, you could remove your whole. You could switch environments, your Python virtual environment, so you could remove the whole environment and start over. But the bottom line is, I basically, you go around in circles a little bit. So from a time perspective, it's hard to tell which one was developed first. But notice the install does a force reinstall. So it tries to get all the compatibilities. So now notice what I got here. I got a maximum token reach exception. I'm gonna ignore that for now, but what I think is let's first read the output, because I specified in the model I wanted to use 1,000 tokens. And then I wrote that file to disk, and now I'm running it. So, but let's see what output we got so far. Okay, so it looks like I'm pointing to the model, the instrumentation. Okay, I'll search for cowboy theme attractions, rodeos, museums. Tool 1 web search, tool 2 web search, tool 3 web search. What is it doing and why? We'll have to take a look at that, but it went and got my credentials out of my credentials file, and it got some responses from some queries: Western themed attractions, cowboy, bars and saloons. It went and did some of these things. Let me search for more specific information in Western themed museums. Web search 5, 6, 7. It got some responses. American Museum, Natural History, Buffalo Bill Museum, Coyote, Ugly. I don't know how it got these queries. We'll take a look at it. Now I have, well, the thing is, it told the LLM model what it wanted, and the system prompt basically said, you're an intelligent agent, which does this. So basically, the LLM model basically figured out what was in that category and started hitting on these things. But now here, based on the current information, cowboy vibes and rodeo travel guide for New York City, rodeo events, what it is, a professional bull riders championship feature, location is Madison Square Garden, when, 30 days. Now notice the system prompt, you can specify what you want and how, whether you want this in a bulleted form or in a summary form, or whether you want 3 lines or 6 lines. So Anthropic is, some of the models they do a good job, a very good job, and it's pretty thorough. Now here's your Brooklyn rodeo events, but you can control this, and like I said, when I see this stuff, I think of an API request and response, and the response, typically is used for input in another request, and as long as it's large language models and agents, it's not a problem. But if you're calling APIs or doing something different, you have to worry about inputs and outputs, and and how this is all going to work. As far as prompt engineering, it's you know, the model can help you communicate and stuff like that, but it is wordy and you are paying for it. So let's see, what is this? Here's a flaming saddle saloon, and it tells you a little bit about entertainment menu. Coyote Ugly Saloon, hours of operation, blah blah blah. Other bars. So I think the point of this demo is observability. So let's just scroll down to see what happened. I'm not going to worry about the errors. At this point, I just want to show you what's going on here. We got a max token reach exception. Now, I could increase the number of tokens and run it again. I don't know if I'm paying for these with Haiku, but that would be my first thought would be to do that. Of course, I have to write the file again with the number of tokens specified, but I'm going to continue now. Now, this is a travel agent with session. It's writing this file, and it gets written here because I just ran this before. Okay, so it's using some open telemetry stuff, baggage and context, and let's just see what this thing does. OS logging or parse, open telemetry, parse arguments. It parses arguments. It sets the session context using the session ID, and it attaches the context. So it gets the context using the session ID, and it uses this context object to attach the context with the session. So it has this session ID attached to the telemetry context, then a return token, agent code below. Okay, so we're using Strands, agent and tool. We're using Strands models, which is Bedrock model, and we're using DuckDuckGo, which is that web search tool which aggregates results. Use it a couple times. They use it a little bit in these demos, and it seems to be simple. It seems to be useful. So here they put a tool annotation on this web search. Here's your tool that you're importing from Strands. It uses these annotations. You instantiate the object. You query the result. You pass in a query. Query is coming in as an argument. You format the results. Result get, title, body, result get. Join. Now it joins the results. Now here it gets the Bedrock model, uses Haiku, West region, different temperature, maximum tokens, successfully initiates the Bedrock model, and it has a session, context token is the session. Get the Bedrock model and then instantiate a travel agent. So the difference between these two files is one is a travel agent and one is a travel agent with session. So let's take a look. You are an experienced travel agent and personalized travel recommendations with access to real-time web information. Your role is to find the dream destination matching your preferences using web search. You should provide comprehensive recommendations. Looks like the same system prompt. The user ID, and let's see. The tools used here, and the user ID is used here. Now let's see how the user ID is associated with the session. Where did we create the session? So basically, what has to happen here is that the customer or the agent has to get something and keep track of something, and there's usually a session ID involved. So we'll take a look at the difference between the two in a minute. But right now, this pretty much looks the same. And then you define main, you instantiate an agent. The only difference is you're using a user ID here and a session. So this is supposed to make it a unique ID. But let's just see. Research, looking for the same thing. It's the same query. Finally, in the final block, it detaches the context, and session for this is detached. Okay, and then it ran. So let me just write this again, although I just previously wrote it. It's still here, and now we're running this command line with a session ID. Okay, so let's do that. And I keep getting these warnings. So in some sense, we're finishing running all the cells in this Jupyter notebook. And it's getting responses now. Looks very similar to the previous run. However, we are using a session. And once again, the maximum tokens is reached. Now, like I said, let's stop here for a moment and take a look. This is an observability package. It's an agent that's not hosted on Runtime. We've executed 2 runs, one without a session and one with a session. So we're going to go to README, and we're going to read the README file and figure out what's going on. Now here, model-driven agentic development, complex workflow with custom spans. Okay, now spans are what the agent is doing step by step. Think of it as segments of a trace, right? So first you call this, then you call that, then you call this. So you look at the span, you look for the performance, you look at the observability, you get a good idea what you're dealing with. Let's see what they have to say. They're not saying anything. That reflects the different sessions. So let's do this. Let's go over to let's go over to the observability and see if we see the difference. Okay, so I'm going to click on this, and let's see. How do we get where we want to go? It's not very straightforward, but CloudWatch logs, let's say settings. View the X-ray settings. Looks like it's enabled. Let me go to see a Bedrock Agentcore. Okay, now here's my agent travel strands. So let me go into that. Okay, now I'm looking at the agent metrics. These are the traces, these are the sessions, and these are the evaluations. Okay, so this is overview of the loop cycle. And so it looks like I got 4 loops. And what I interpret that is like the customer asks the agent something, the agent respond. The customer asks the agent something, the agent respond. And we invoke the Strands agent 4 times. This was the Bedrock model. And I could drill into the traces, but let me see what I want to look at, okay? So here's my sessions and traces. Here's my token usage. So when I look at token usage, I look at expense, right? So I used a bunch of output tokens, and I'm paying for them. Input tokens, output tokens. Okay, so I'm paying for those. I gotta keep track of that. And then here I have 2 traces and I got 1 session and 2 traces. So basically I could analyze them. 1 session, 4 traces. Now I got an error here, system error. So now let me do this. Let me look at sessions. Okay, this was my session that I created. Let's see what kind of information I have. I look at my total tokens, and I have 2 traces. If I look at traces, I have a bunch of traces here, and notice these span numbers. So in 1 trace, I'm getting a bunch of spans. So we're going to look at that in a minute. Let me see what these inputs are. Research, recommendation. And here's the input. Let me go back to sessions. Let me drill into the session. I'm getting nothing for, I got 2 trace IDs. One has 17 spans and one has 11. So let's see what this is. This is the content, and this was the output. And let's look at the second trace. Okay, went through event loops. Now notice I want to point out the number of seconds here. This is a very hard problem to optimize, right? So think about how you would optimize this. So the loops are taking 11 seconds. Not good. It might be good for someone who's twiddling their fingers and looking at their email or whatever, but the bottom line is this is true. Now it executed the tool several times. One time it took 1 second, another time it took 1.61 seconds. And it spent 2 seconds in Claude, obviously. Okay, so think about this. How are we going to speed this up? We could use a tuned model. We could cache web search results. We can optimize the APIs. We could do different things, but just pointing out that this is what I'm thinking about when I see this. Now, this is what I want to see also, the trajectory. So let's take a look at this real quick. I know this demo's kind of long, but you know, the bottom line is it's simple, and we do want to get the most out of this demo, as simple as it is. So let's see, what does this look like? Okay, so I invoked this Strands agent. I invoked, executed the event loop. I did I got my foundation model. I did executed on web tools. And let's see if I could get any information out of this. What is this? We don't know. There's no events. What is this timeline? We get to see the timeline of the events, when they happened. And like I said, look where we're at, 11 seconds. I mean, our goal is to make this faster and more precise. And so the big question I'm asking myself was, why is this web search tool being called over and over again? I know it's aggregating, it's searching for different phrases, and it's aggregating. So not that that's taken too much time, but if you do want to save some time, you can reduce that somehow. So that's looking at the trace. Let's look at this one. This looks like I got some warnings here. Well, we know we got a problem with the so I would want to know what this is. So there's 17 spans. So are we seeing all 17? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. $65 events. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So it looks like this span included each step, which is, it's good. I mean, you want to know if the chat took 261 seconds, you'd want to know how much did Haiku take. And so if this number was much bigger than this, it would have been that we're communicating with a large language model, and this, before we reach it, it's taking a lot of time. But it looks like most of the time is in the large language model, and I think that's because basically, you know, when we call a large language model, if I'm on the East Coast, it's going to go and get the East Coast. If you're on the West Coast, if we're running on the West Coast, we're going to call the large language model on the West Coast. Let's see what I'm doing here. I'm in the West region. But anyway, either way you look at this, these numbers, you got to think about, you know, millions of users using this, and how do these numbers get affected, and how are you going to optimize something like this? Anyway, let's go back here and let's look at traces. Now, I think this trace was not one of them that was associated with the session. There's 23 spans. They're all taking a lot of time. And we took a lot of tokens here. It's a lot of latency. 24 seconds. Trajectory looks a little bit more complicated. How do I make this thing bigger? I just want to just want to look at the trajectory here. Okay, we got more event cycle loops here. One's executing tools. They're all executing tools. Okay. Well, you know, like I said, we are getting observability, and if anyone knows, you know, how difficult observability is, and we are seeing how different observability is with Agentcore agents and agents in general. Basically, you have to look at the request to response and what sequence of events did you go through to solve, to respond, etc. And what we're seeing is these large numbers. So what we can do you know, what's typical, although Haiku is pretty optimized, but what's typical is change a large language model, fine-tune your large language model, distill an existing model. There's a whole bunch of things you can do to try to get these numbers down quicker. However, the thing, some of them might reduce this number, and these numbers you can reduce in a different manner. So think about that, and basically what we want to do is end this demo. Let's see if and these images here don't really show me much. We have transaction search already enabled. So I think that's all I want to do, and we could do one more thing just to see what happens before we end the video. Up here, my maximum tokens were reached, and I had this many tokens. Now, once I change this, I'm paying for it, right? So I got to be careful with this. Let me, this is Strands Observability. Let me close this. This is which file? Strands Travel Agent. Let's see if we get the error again. And I noticed we had the parameters different on these models. For example, this we had a temperature of 0. And the other one we had a temperature of 0.7. So that's going to affect the performance as well, because when you have a temperature that's closer to 1, you're calculating more probabilities and varying those results based on those probabilities. So I did not get an error. However, I did pay more money. See if we go back. Yeah, so I'm gonna. I think I'm gonna end this, but let's just quickly see. You know, it would be nice if we saw the cost here for the number of tokens. What I'm gonna do, because I'm getting a little confused about this. Why don't I just remove this? I just went through this. I forgot what I did, but the tokens is now 60.9. I'm going to run it again just to see if that goes up. I really wanted to run this thing. Yeah, I really wanted to run this thing. I think Amazon did a very good job with these folders. This project and be able to run them and look at the results and everything really is a good experience, especially when you're trying to learn Agentcore and you know, you're trying to excel and save time. So notice my tokens are now 90K. So I'm paying for these things, so just keep that in mind. So we are going to end this demo and move forward. Let's see, we did this demo here. Occasionally I do the lane graph and the llama index, but they just duplicate with different type of frameworks. So it's good to run them. And so I typically have no problem with the lane graph, but when you get into crew AI and stuff like that, you might have problems. Okay, anyway, let's do this. Oh, this is running. I think it just okay, and the other thing I'm looking for here is the cleanup cell. So now if I come here, let me refresh this. I just want to see what my final token count is because I don't know what I'm paying for this. My bill on Amazon is usually huge because of this, but it's really so now I'm at 121K. So okay, so now what I want to do, I do want to delete this, but I just did it a minute ago. I can't remember how I did it. But I'll end this video and we'll go back and I'll have to clean house explicitly, or I will create a cell that cleans this up for me. It's never a good idea to not clean up. Okay, that's all I want to show you. Thank you.